Hi everyone, my name is Courtney Brown and I'm a Senior Marketing Manager here at EDB. I'll be your host for today's Public Sector Virtual Town Hall on high availability for Postgres. I'm joined today by Steve Foley, VP of Public Sector, and Matt Lewandowski, Field CTO. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides with everyone after the broadcast. All of your lines are muted. If you have any questions, please feel free to submit it in the question panel below. Today's session is scheduled for about an hour, and we expect the presentation to last most of the time. We'll allot any extra time for Q&A at the end. If we aren't able to address your question, we'll be sure to follow up after today's session. And now, without further ado, here's Matt.
Hello, and thank you, Courtney. As Courtney mentioned, I'm Field CTO, doing a lot of work with the North American Public Sector team and support Steve Foley and his team in their efforts working with customers in your environment. Anyways, today's agenda for this webinar is to talk about high availability and how that is managed through EDB and Postgres. We'll first give you an overview of some concepts of high availability, introduce some topics related to high availability in the way of RPO, RTO, and uptime. We'll also discuss how high availability is works within Postgres, talk specifically about streaming replication and a wall-based shipping of logs. And we will also go over some parameters related to high availability for that wall shipping as well as streaming replication. And we'll talk about EDB specific tools to help you manage your high availability environments. First of all, the concepts. It's probably worth just a quick definition of what high availability is. If you do a Google search, you can come to a Wikipedia definition of it, and that's shown there. Basically, it's a characteristic of a system which aims to ensure an agreed level of operational performance, usually expresses uptime or a higher than normal period. So we'll touch on what uptime means a little bit, but for high availability itself, there are three key principles that we use in the design of a system that would be highly available. One, you want to eliminate single points of failure. And then you want to establish the ability to perform reliable crossovers. And then you also want to be able to detect failures. So we'll keep those key principles in mind, and we'll come back to those in a bit. Also, when we talk about availability, we'll often talk about the downtime. And that's obviously times when the system's not available. And there will be two basic classes of downtime. There'll be the scheduled or planned downtime. Those are downtime activities associated with things that you need to get accomplished on the system, but also require that the system be taken offline, at least temporarily. Sometimes that is a short amount of downtime. Sometimes it's a little bit longer downtime, but things that would fall into this category where you might need to do software patches, swap out hardware, or things like that. And then you have the other class of downtime, which is unscheduled or unplanned. And those are things that obviously you're not anticipating, but perhaps you have a power outage or you have some failure in your computer based resources, maybe the network, or even some sort of security incident that causes the system to go offline for a while. So both those things can factor into what you design for high availability. Usually when we talk about availability, we express it in uptime, and people often express it in terms of the number of nines associated with that uptime. So they'll say a 4 nines. That means that the system is available 99.99% of the time. And if you say 5 nines, 99.999% of the time. And then if you look at the downtime associated with that, the times that are available, oftentimes you'll consider that as that. So if you look at a 4-9 situation, we're talking about 52 minutes or so per year. And if you were to get really a more highly available system, say a 5 nines, then you're talking only around a little bit more than 5 minutes per year. So you can see that those are some goals that systems that need to be up and running for a longer amount of time, they shoot for those kind of numbers. Oftentimes too, whenever we talk about availability, some organizations won't actually include the downtime, the planned downtime as part of that number. So it's something probably as you're looking at service level agreements with a service provider, you might want to understand that. Some related topics are RPO, RTO, MTTR, and GRO. And I'm not going to dwell on these too much, but they do factor into what sort of system you need in place to be highly available for you and your organizational requirements. So RPO is a measurement of the time since the failure, the amount of data that you can lose. So RPO might be, say, 2 hours. You can afford to lose the last 2 hours of data when the failure occurred, as long as you can get to that point. Some systems can't afford that much data loss, and they need to be designed to minimize that to maybe within minutes or even seconds. And so depending on what your needs are, this is a goal to shoot for. Then you also have recovery time objective, and that is about how long it's going to take to recover the system to where it's functioning again after an outage. And so RPO is really focused on the amount of data and time prior to the outage that you can accept as a big loss, and RTO is forward from the time of the outage, how fast you can get back to an operating state. And they are in dynamic tension sometimes. Sometimes it might take longer to meet an RPO objective or recovery point objective for and also meet your RTO. So you have to balance those. Also, these things may play into what sort of systems you have in place in the form of like disaster recovery and such. There's also a related concept called mean time to recover. This is the average time that it takes to recover from an outage. Oftentimes that will be expressed in service level agreements. Keep in mind though, it doesn't always mean that every outage can be recovered from in that amount of time, but rather just an average. So some events are going to be more catastrophic in nature and they might take more time to recover than this, but this is often how requirements for a system are expressed. And then we also have the concept of geography recovery objectives. I like to think of this as that, you have a couple different aspects to it. One, you need to be available in a certain geographic region for certain operations. Imagine like a satellite control system where you have access to a satellite from only certain points around the globe. That geographic region needs to have access to its system, and you need to be able to recover with the sufficient RPO and RTO measures to support that. But you also could have a system where you might build in geographic redundancy so that if something happens at one system in a geographic region, that you could fail over to another geographic region in a fairly short amount of time and then maintain a higher level of availability. So some concepts just to think about as we continue our discussion on this subject. So from a perspective of Postgres, we'll think about those design principles that I mentioned earlier. So let's think first about the elimination of a single point of failure. Postgres supports that through the ability to be able to create replicas of your Postgres databases. There's a couple different ways of doing that. But primarily, that is being done either through wall shipping, and that's probably a little bit older way of doing it, and more recent ways of doing it is the streaming replication way of doing it. So under the wall shipping way of doing it, you basically send your transaction logs, or what in Postgres vernacular, the write-ahead logs, you'll archive those to a location, and then your replicas will, which were created from an initial backup of your running system, will then read those transaction logs basically from the archive location. And then with streaming replication, you're establishing a connection between the primary database and the standby databases, and the standbys are getting the updates or the wall in a little bit quicker fashion as they're occurring on the primary. And then there's a third option that's sometimes used called logical replication. In the first two cases, wall shipping and with streaming, you're basically creating a binary copy of your database as a replica, and it requires that the databases be of the same version and a major version, that is, and running on the same OS. Whereas with logical replication, you have a little bit more flexibility. And what it's doing is it's reading the changes that are occurring in the database, and then it's issuing SQL statements based off of those changes to those that are subscribers to that information. Logical replication also provides some flexibility that it can be just a subset of your database. The databases don't have to be on the same at the same major version. They also could be running on different platforms. And then there are some logical replication capabilities with other data sources as well. But primarily, that's an option that some folks are considering more and more. It doesn't have quite the same performance characteristics as the first two there, but there are certain situations where that's probably a good option for you. If we continue with our elimination of single point of failure, one of the options that are available for your wall shipping as well as for streaming is a concept called hot standby. Basically, with a hot standby configuration, you set up the standby databases so that you can actually connect to them and read from them. So that allows you to offload some of your reporting workloads, say, to the standbys and actually use these resources as opposed to just having them ready there in case of a failure. Also with hot standby, that configuration supports a slightly quicker repurposing to become the primary in case the original primary failed. And again, I said that it works with both the wall shipping as well as the streaming configurations. So we look at hot standby from the perspective of a wall shipping configuration. Basically, in that configuration, you're going to have a primary database. That's the database node shown there on the left. And you will send its wall to an archive location. And then the standbys will have been set up, and they'll be able to read that wall from that location. So sometimes if you have, say, a single standby and you're just shipping those logs directly to the standby, that's an option. Or you could be shipping it to a centralized spot where multiple standbys could be reading from that. That might be a more common configuration these days. But the key parameters there are that you have the database configured for wall level of replica, and then you have an archive command set up on the primary. And then on the secondaries, you'll have a restore command so that you know where to read that information from. And then have the database configured for hot standby. And then there's some options around what timeline you want to be able to recover from. And that supports some operations related to how you, in the case of a promotion of a standby to a primary, having the other standby and become a standby of it. Postgres itself provides some capabilities to help you monitor the state of your replication in a wall shipping environment. It has a function called pg is in recovery. And this is basically a Boolean value that says, is this system in recovery? So in a standby database, that should be true. If it's not true, then you're the database, if it's running, is not a standby database. So it thinks it's a primary database. Then you have two sort of related functions, the pglast xlog /wall replay location /lsn. The slashes are there because previous versions of Postgres functions and directories and such, they previously named those xlog. More recent versions thought it made sense to label them as they are known by the Postgres community. So that's hence xlog became wall. And then LSN refers to the log's sequence number. That more accurately reflects what we're talking about there. So in that middle one there with the location or LSN, we're talking about the number of basically bytes difference that function will help you identify between the primary and the standby. And then also the third one there, the replay timestamp, helps you understand how far behind you are from the primary. And then like these wall shipping, we also have the ability to do this with streaming replicas. Streaming replicas, I mentioned earlier, you basically are establishing a connection from the standby to the primary databases. And so your setup's going to be a little bit different in that regard. With the streaming replication configuration, you need to identify that you a number of wall senders, and that should be equal to or greater than the number of standbys that you have for that primary. And you can also configure a number of replication slots that would be used by that streaming replication. And if we look at the standbys, you'll see that there's a primary con info in there. That's basically where you establish connectivity to the primary database. But since you need to connect to the database, there's some things that you need to configure in the pghba.com file. That file, for those of you who are familiar, who may not be familiar with Postgres in detail, that's the host-based authentication file. And that basically says which clients can connect to this database and for these purposes. So there's a specialized label for the database. It's not actually a database that they're connected to called replication. So for streaming replication, you need to make sure that you have entries in your host-based authentication file that allow replication to send information to the standby databases. So they need to be able to connect to the primary. I think that, and there's other options within the standby that you need to configure. If you want to simplify promotion of that, you can use a promote trigger file, although there's probably more preferred ways of doing that today, but that is an option. We're talking about hot standby here, so obviously we want to set hot standby on, and that's a configuration that will allow those databases to be accessed and process read queries. For streaming replication, there's a couple basic options you have available to you. You can either do that so that it's asynchronous replication or synchronous replication. The wall shipping option does not offer synchronous, it's only asynchronous. And I would say in most cases, at a lot of applications, asynchronous replication is more than good enough even for streaming replication. But there are some applications where they can't afford much data loss, if any at all. And so they don't want to be behind. So with synchronous, when you write something on the primary, that won't be completed until it's guaranteed that it's be written on one or more of the standbys, depending on what you've configured in the synchronous standby names parameter there. So there's some different options associated with setting that up. You can say that I want to configure it so that the first of any standbys that I identify, as long as it's received that and applied it, then I can proceed with the rest of my transactions. Or you can do an any number. So in this case, you'll see an example there, it says any three. So any three of the standbys that are listed there, as long as they have that. And that becomes a quorum-based way of saying that the standbys are caught up, at least the number that I said that I need are caught up. And then there's a third option, which is a little bit older. It's sort of a shorthand for the first example there, first one. As long as one of those is configured and has applied the changes, then we're okay. Related to all this is a synchronous commit parameter. And I would say the first two, they're often local, primarily mean that your system is operating in an asynchronous mode. The other three are more applicable for a true synchronous configuration, with the last of those, remote apply, being the one that's most likely to guarantee that you will have the changes from the primary actually applied on the secondaries. Just like with while shipping, the streaming replication provides some capabilities for getting information about the status of your replication environment. From the master or the primary database, there's a view called pgstat replication, and that offers information about what sort of lag is in the system from the perspective of the primary database. And then the standby database, you have a similar PGUL receiver that looks at it from the perspective of the standby. So that brings us, that sort of goes over how we handle the, eliminating the single point of failure. And that's by creating redundant systems or replicas of the database. The second and third principles for a high availability system are having reliable crossover as well as detection. So with a reliable crossover and detection, actually there's, if you have the redundant systems in place, and if you have reliable crossover points and you can establish that, then oftentimes users may not see the failures at all. However, you still want to be monitoring for those in case, that there is some issue with that crossover itself. So to be fault tolerant, you should provide a reliable crossover capability and switchover capability. And EDB has some capabilities around that area. And primarily, the tool that we make available, there are other tools in use with Postgres, but we're very proud, and our customers find the EDB Postgres failover manager to support their needs very well. And I would say it's often considered, one of the better tools out there for this sort of thing. It is what it does is continuously monitors your replication environment, and it'll detect any failures in the system, either in the primaries or in the standbys, and it can send alerts to you if there are issues. But more importantly, it can automatically fail over to the standby databases, to the most current one, or one that you might configure as being have preferential. There might be a node you want to go to, but it will go to the most current standby otherwise. And you can also configure it to work with load balancers such as pgpool, so that it can reconfigure those load balancers so that they point to the new primary database for its write activities. And it also has ability to avoid certain scenarios like split brain, where the system could, if you weren't careful, if you thought that the primary database was down, but when in fact it wasn't, and you somehow promoted a standby to become a primary, then you could end up with a condition where you have multiple primaries, and that wouldn't be a good scenario to be in. EDB actually provides measures of protection against that, and thus minimizing your data loss. This is an architecture diagram of a way EFM is configured and is set up. Primarily, you will have at least one primary database. You'll have one primary database and at least one standby database. You'll need at least 3 nodes in the system. So if you don't have more than one standby, then you need a witness node, which for a witness, it doesn't necessarily need to be on a node where a database is installed. But on those database nodes or on the witness node, you will have an EDB failover manager agent. Those agents are in communication with one another, and they you need at least 3 so that you have multiple looks at who's available on the network, and making sure that that there's a quorum of to make that decision if there's a problem with one of the nodes. And the agents themselves will connect to the local database. They'll periodically do checks and against making sure that they can connect to the database. If they're not able to connect to the local database, then they'll send out a request to the agents on the other servers so to have them try to connect to that database. And then if it's determined that the database is in fact down, then it will configure the standby database that's most current to be the new primary. And so that's generally how it works. There are obviously some different configuration points within that for controlling different aspects of that, like how much time between checks and how much time to wait for the established connections to the database and such. That's all built into it. It also, as I mentioned, can work with load balancers and reconfiguring them. So like in the case of PG pool, which is a common one that's used, it can reconfigure PG pool to point to the new primary if the old primary was taken offline and one of the standbys was made a primary. So that sort of handles, I would say the higher availability use cases. Oftentimes organizations will still need to provide some disaster recovery capabilities in the form of backups to meet some of the RPO, RTO objectives that you might have. So EDB provides a tool called Backup and Recovery Tool, or BART as we affectionately call it within EDB. And BART is a tool that allows you to manage your backups. You can use it to schedule backups, mark backups as being obsolete, delete old backups, and it works with multiple versions of Postgres, including both community Postgres as well as advanced server, which is an EDB version of Postgres, and different versions of Postgres within those sets. And it also provides some incremental backup capabilities. So for larger databases, where it would take a long time to perform a full backup, you could perform an initial full backup and then do some incrementals, which would be quicker and also take up less space than another new full backup. And then those also lead to being able to restore a little bit quicker. It does support point-in-time recovery, where you can restore to a specified transaction ID or to a specific timestamp itself. The BART can be configured in one of 2 ways. There's a traditional command line interface that we provide, but it also it can be configured through our Postgres Enterprise Manager tool, which I'll talk about in a little bit, but that provides a GUI mechanism for configuring BART. BART basically is installed on the server. It has configuration points to identify the different Postgres databases in your system, where backups are stored, and where the write-ahead logs are also archived. And then with that information in mind, it can be used to restore from that set of information. So let's say you have a full backup with an incremental, and then you have those WAL archives. So it'll help restore the full backup, restore the appropriate incremental backup, apply any WAL that it needs to apply, and then that gets you to the point where you need to be, where you're expecting to be from your backup that's been restored. So that covers like some of the cases where you might use that for a disaster recovery or recovering from an event that wasn't handled well by just a high availability configuration with EFM. Say there was somebody who dropped a table and you didn't have EFM configured so that you had or streaming replication configured so that you didn't have a time delayed replica. You may go back to using a backup to restore to the previous point. Related to all these is the concept of needing to do monitoring. In fact, in preparation for this meeting, I did some reading, and the number one thing that causes outages is the lack of monitoring in the system. And it's really important to sort of have a handle on what's going on in your system so that you can actually prevent problems from occurring that might actually cause an outage. So EDB does have tools to support that. We have a tool called Postgres Enterprise Manager, and that provides a single pane of glass view of your different Postgres databases and the systems that they actually reside on, and it provides dashboards of that. We provide over 200 built-in alerts. So for PEM configurations where you're using our PEM agents to monitor a database and its system, you can use those probes and alerts to notify you when there's a problem that needs to be addressed. So it'll look at things like memory utilization, CPU utilization, storage available on your system, and other things that are going on in the database. And those alerts can be configured to with different threshold values. So things based on your requirements that can be configured to send out notices when those thresholds are met. And it does aggregate performance and status data. It does provide the ability to display those in graphs and tables within the PEM interface. The PEM interface itself is a web interface, so it's no special client needs to be installed for that, and helps you just basically monitor the overall health of your system. It integrates with other monitoring tools as well. So if you have some popular monitoring tools you're using already, you can use PEM to work with those. And it has the added benefit that it can do a lot of different Postgres management features, like creating database objects, managing those objects, reviewing SQL queries, executing SQL queries, performance tuning, doing other performance diagnostics. So there's a slew of capabilities that go beyond just what's available in the way of monitoring. The basic architecture of PEM is that you have a web application, an Apache HTTP application with a PEM database that it stores the PEM configuration as well as information that it collects from the different servers and their probes of those databases through the agents. It can be used with managed databases, meaning that we have an agent installed with the database, and that agent is collecting information, it's sending it back to PEM. It's also assisting with sending out alerts as necessary, or it can be used in an unmanaged way. You can connect to databases and get information about the objects in that database and different other aspects, but it's not using those agents to collect that information interactively. And then, as I mentioned before, that it uses web browser as the client, so clients connect to that and they can have access to those different databases and the systems on which they reside. So that kind of covers the tools that we provide in relation to high availability solutions. I think a good topic that is often asked about in relation to this is how do we do maintenance and with planned downtime so that we minimize the amount of downtime associated with that maintenance. Why would we even want to do that, first of all? As many of you probably know, most software vendors want you to be up to date. And that primarily is because we've taken the trouble of creating, introducing bug fixes and introducing security fixes. And also, more recent versions are generally going to be more stable and are we improve the reliability of our software with each version. So software vendors, will provide software updates for those purposes to address known issues and to increase the stability of your system and also to address security problems. So that's why we have the need for it. Most updates need to be performed by at least temporarily taking your system offline. For EDB, for Postgres, it's pretty straightforward. You need to basically install the new updates for minor updates, which are just replacing the binaries, and then restart the system, and those binaries get used. Some users, systems are tempted to just get the Postgres binaries and swap them out for a live database. That is highly unrecommended as a practice. One, you could have some security systems in place that would do some checksums between what's available on disk and what's available in memory, and it might take the system offline because it detects that you have some sort of intrusion or some change in your configuration that was unexpected. Or, and another problem that can occur if you just swap out the binaries is that you may be using extensions that with the new binaries, the libraries wouldn't be compatible. So you really need to be careful for that. So for Postgres, you want to use our installers to update the minor versions, and then you do a quick restart and the system is back up and running. Now, when you have a high availability configuration, you need to think about how you do that. So let's imagine we have one or more standbys in the system. The three strategies that are typically used is an all nodes patching strategy, or a rolling patching strategy, or a minimum downtime patching strategy. With the all nodes patching strategy, you basically will send update each of the systems and more or less restart them all coincidentally. Oftentimes that is done with the assistance of something like Ansible or some other automation tools. A rolling patching scenario is that you would apply the patches to the standbys and then to the primary. One that is sort of like that is the minimum downtime patching, where you apply it to standby and then you perform a switchover of the primary to the updated standby, which becomes now the new primary. And then you can update the primary and then make it be a standby of the new primary. And then if you choose, you can do a switch over there to make it also be the primary again. But that is the option that would result in the minimum amount of downtime. So to this point, we've covered a number of different concepts related to high availability and Postgres. We've talked about our different replication setups. We talked about wall-based wall shipping for replications. We talked also about the more recent and more prevalently used replication technique today called streaming replication. We talked about configuring that for hot standby. We also introduced our failover manager tool, which helps monitor your replication environment. And then we talked about using Postgres Enterprise Manager to help monitor the system, and our backup and recovery tool to produce and backups and be able to restore the database. And we discuss how you might do near zero downtime software maintenance. And we introduced some topics or concepts of RPO, or recovery point objective, recovery time objective, or RTO, and geography recovery objective in the discussion here. And I think that covers most of the technical concepts. I will say that a colleague of mine, Vibor Kumar, has written a number of blogs, really good blogs on this subject. And actually, it aligns pretty well with the contents of this presentation. These are hyperlinks, so when you get a copy of the presentation, you'll be able to go to those blogs and read more about that. We at EDB I've been doing Postgres for well over 15 years. And if you have questions on this front, we're certainly here to help with that. Now I'll turn it over to Steve Foley.
Thank you, Matt. This briefing was designed to be a technical briefing in regards to high availability, but we wanted to share a little bit about EDB, especially around our public sector focus. We'll talk about this for less than 2 minutes, and then we'll jump into the Q&A. But as mentioned, Matt, that we've been around for a little bit over 16 years, but we've been dedicated to the public sector for at least 10 of those years. You can see the customers on the slide here. We are public sector focused. The folks delivering this briefing are public sector folks. We serve the federal market, state and local market, higher education, Canadian government. We have the ability to support some of the most secure classified networks in the world within the intelligence community and the Department of Defense. We have the certifications you would expect from a vendor that served the market for as long as we have. FIPS 142, published DISA STIGs for both Windows and Linux, ATOs in order to operate on DoD networks, Army and the Navy, as well as teams around the country supporting other state and local entities. So very much federally focused, public sector focused organizationally. Next slide, Matt. And for those of you that hadn't heard the news, 2 weeks ago, we purchased our largest competitor, a company called Second Quadrant. We acquired them. And that by far makes us the largest vendor dedicated to PostgreSQL in the world. And with that, we've added a lot of talented new teammates. And a lot of those folks are also contributors to the community. And prior to the acquisition, we said we were most often the largest company, the largest contributor to the community Postgres SQL version. But now we're by far the largest contributor. We have 26 folks that contribute to the community every year. We are absolutely committed to the community, and we want to be good citizens of the community as well as offer our solutions to the marketplace. So we will continue to be dedicated to the community organizationally and drive the innovation in the Postgres SQL platform and software. One of the reasons the Postgres SQL has won is because of the vibrancy and the robustness of the community. And we want to be, and still maintain our part and be a part of that moving forward. So with that, we will open it up to Q&A. Matt, we have a few questions here. How do you ensure HA in a major upgrade scenario?
Yeah, so that's definitely something to think about. So with major upgrades, it's more than just a quick install of the binaries. You have to actually move the data and stuff like that. So for those cases, we often will recommend a logical replication for that. I didn't talk too much about logical replication in this presentation, but that often is your best option there. So you'll basically create a replica using logical replication that'll be of the new version, and then you'll use logical replication to move that data from the old version to the new version. And then when you're satisfied with that, you switch your operations over to the new version and the data that's in there. So oftentimes that's the solution we would recommend for that. And we certainly, if you have questions around that, additional questions, we'll just reach out to us.
Great. Matt, we look like we have 3 more questions here. So the second question, does Failover Manager offer the ability to customize the actions taken in a failover event?
And it does, yeah. So we, many of our customers are happy with the out-of-the-box experience in what we provide, but we recognize that every environment's a little bit different. So we provide hooks in the configuration that allow you to specify shell scripts or other actions that you would take at different points of the process. So like in post-promotion, you might want to take some other action besides what we provide, and then do something different maybe than what we do. You can do that through those different hooks in the configuration. Okay.
Great. Question 3, does Enterprise Manager have EFM integration?
It has some EFM integration. I think we're evolving that more, but you can certainly monitor the status of your cluster from EFM, and you can also use Enterprise Manager to perform switchovers. Yeah, it has some of that, and I would say that more is coming.
Great. We have actually a 2-part OpenShift question. So any issues with HA in a Kubernetes or OpenShift environment?
We actually have a separate strategy for that. That is, we'll probably have more information forthcoming in an upcoming webinar related to all that. I think we're using some other technologies that more germane to Kubernetes and OpenShift for that, as opposed to, say, EFM. But I would say let us follow up with you on that question and how we handle that for that.
Okay, and that might be the same response to the second part, but I'll read it out to you and then you can reply, Matt. So do we get all the features of monitoring and backup in an OpenShift environment?
So it'll be done probably in different ways than what I discussed here today. There are some tools that are in the community that we would be using for those that have been sort of geared towards more of a cloud native way of doing things. So again, I think that's a good topic for a Kubernetes containers webinar in the future. Okay.
Great. And for the folks who are asking, the OpenShift Kubernetes is, as mentioned, we acquired a firm called Second Quadrant that was down the path with solutions, and we are collectively looking at our solutions and Second Quadrant solutions and working through our path forward, and that'll be determined here in the very near future. So, both organizations were heavily invested in Kubernetes and OpenShift, and we're figuring it all out in real time. So we'll be back to you shortly in regards to our path forward and more details around your questions.
And I would say the good point is that we do have Red Hat certified images and operators, and all the things that you're concerned about with monitoring and backup are all things that are built into those solutions. And we're just going through the step of reconciling the two offerings and making sure that we present those in a way that's clear to you guys.
That concludes the Q&A. Courtney, over to you.
Great, thank you, Steve. And just a reminder for everyone, we'll be sending the recording along with the slides after the session as soon as possible. Thank you all for joining us today, and we hope you have a great day. Thank you.
Thank you, everybody.